Hey y'all, it's Mr. Smith again. Today we're going to be looking at rate of change, aka slope. Um, the EQ for this lesson is how can rate of change help or be applied when solving real world problems? Well, rate of change or slope, I'm pretty sure you have been working with at least since seventh grade. But we're going to kind of go through everything, and hopefully this will be a nice little refresher or catch up for you. So as you can see, we have four graphs. We have graph A, graph B, graph C, and graph D. And each of these graphs are different. They all have four different rate of changes. So when we look at the first graph, all right, tell me, which one of these do you think has a positive slope? Which one do you think has undefined slope? Which one has a negative slope? And which one has a zero slope? All right, so let's go through them and see if you got it right. So let's look at graph A. So when I look at graph A, I can see that it does have a positive slope or a positive rate of change. Example of that would be m is equal to 1/2. We could also have m is equal to 2. We could have m is equal to 3/4. All these are examples of positive slopes. In graph B, when we look at graph B, we can tell that it is a negative slope or a negative rate of change. So we have m is equal to negative 1/2, or we could have m is equal to negative 2. We could have m is equal to negative 3/4. So as you can see, in order for it to be a negative slope, it has to have a negative. If we look at the graphs, whenever we read, we always read from left to right. So when I read this graph from left to right, we see that it's going up and therefore a positive slope. When we read graph B from left to right, we're going down, hence a negative slope. Graph C and D are the two graphs that most people get confused. One is zero and one is undefined. Um, Graph C is actually our zero slope or our zero rate of change. One thing that my old school teacher used to tell me is that if you can place a zero on it, then it's a zero slope. So if I put an actual zero or a circle on top of that line, it would not fall. Therefore, it is a zero slope. Um, Please note, if you're using the formula, you will get zero in the numerator. So if you get zero in the numerator, it is a zero slope. And so obviously graph D has to be our undefined slope or our undefined rate of change. And this occurs whenever you get zero in the denominator. So we have zero in the denominator. Zero in the denominator is undefined. Zero in the numerator is zero. Please note, if you try and draw a zero on this line, the zero will just fall down. Therefore, it is undefined. So I hope these quick little graphics will help remind you of what these four graphs mean. So going on, slope of a line can be defined as the steepness of the rise over the run. So the steepness of the rise over run. So there's a couple of ways that we can find slope. The most common way, or the one that most people remember, is rise over run. So this is method one. It's very important that you understand both methods because sometimes it's better to use rise over run. Sometimes it's going to be better to use the other method. Typically, if you have points that are clear, like in this graph, we can clearly see that we have a point right there and we have a point right there. So we can clearly count the rise and clearly count the run. So in this example, we rise to, so from this first point, we rise 2, and we run 1. So we get 2 over 1, which is equivalent to just 2. So the slope in this example is 2. The other method that we can use is the change in the y's over the change in the x's. So we have to remember that m is equal to y2 minus y1 all over x2 minus x1. So if we have the following point, if we have 0, comma, -3, so negative, and let's say we have 1, comma, -1, and if you notice, I just took those 2 points that we just used. I'm going to label them x1, y1, and then we have x2 and y2. And so for y2, I have -1, so this is equal to -1 minus y1, which is -3, all divided by x2, which is 1, minus 0. And so we're just going to do some quick little integer operations. So we have 2 negatives, so it's like we're adding this together. So we have -1 plus 3, which will give us a positive 2. We have 1 minus 0, which is 1. And we just talked about how 2 divided by 1, or 2 over 1, is just 2. So these are the 2 methods that you can use. You need to know both of them. Both of these come in handy, and it's very important that you recognize when it's better to use one over the other. So in this example, they ask us to find the slope of the given line using both methods. So let's start with method 1, which is rise over run. So we have our rise over run, which is just rise over run. So I'm going to start with this point here. And I'm trying to get to this point. So to get from this first point to the second point, I have to go down 1, 2. So instead of rising, I'm actually going down. So it's going to be a negative, I get my pen to write, a -2. Sorry about that. It is a negative. Scratch that. Hold on one sec. I apologize. Clear that up. Try this one more time. We have -2 over, and then we have to run from where we left off. We have 1, 2, 3. So we ran 3. So our slope would be -2 over 3. So that's one way we can do it. The other way we can do it is using our m is equal to y2 minus y1 all over x2 minus x1. So I'm going to erase this top part so I have a little more room to write. A little eraser, bigger, clear this out. So in order to do this, we have to know the ordered pairs. So for our first point, or the point that I labeled 1, that would be -4, comma 4. And for our second point, we have -1, comma 2. So I'm going to label them real quick. So we have x1, y1, and we have x2 and y2. So for our y2, we have 2, and then we have -4, all divided by x2, which is -1, minus, and then x1 is -4. So in our numerator, we have 2 minus 4, which is -2. In our denominator, we have double negatives. So those are like adding. So we have -1 plus 4, which will give us a positive 3. And if you remember from what we had before, it's the exact same answer. So let's move on to the next one. In this next example, they tell us to find the slope of the given line using both methods. Well, in this, if you remember from the picture, we can draw a 0 on top of this. So the slope is a 0 slope. So if you recognize what the picture looks like and you recognize the characteristics of a 0 slope and an undefined slope, you don't have to waste your time using the calculation. If you do choose to use the calculation, you will still get 0 in your numerator, and you'll end up with m is equal to 0. And so I'm going to do one example. For those of you who have me as a teacher, you're actually going to get ready to do some problems. So what I'm about to do on this presentation is exactly how I want you to do every single problem. So first, I know some of you are lazy, but I need you to show every single step that I'm about to write. So the first thing is write the problem. So as you can see here in blue, I wrote the problem. The next thing we need to do is label x1, y1, x2, y2. So we have x1, we have y1, we have x2, and we have y2. Remember, it's always x comma y, and the reason why this is 1 here is because it's the first point. The reason why this is 2 here is because it's the second point. So always x comma y, and the 1 stands for the first point, the 2 stands for the second point. So we have that done. The next step is to write the base equation for slope, which is m is equal to y2 minus y1 all over x2 minus x1. So we wrote that. Next, we're going to fill in x1, y1, x2, y2. We want to worry about m in this case. That's only if you're trying to find one of the actual x coordinate or y coordinates. But anyway, in this problem, our y2 would be -3. I'm actually going to do something. I'm going to go and write in the fraction bar. I'm going to write in the minus because those aren't going anywhere. And so now our y1 is 0. Our x2 is 3. And our x1 is -3. So in red, I wrote the 2 minuses in the fraction bar because for some reason, some students forget that there is a minus in between. So please don't forget that. So in the numerator, we have -3 minus 0, which is -3. In the denominator, we have 3 minus -3. So we have double negative, so it's like we're adding it together. So now we have 3 plus 3, which is 6. Oh, select it off, 6. There we go. And this reduces to -1/2. So therefore, m is equal to -1/2. Again, this video just basically goes over how to find slope using both rise over run and the slope formula. Remember, this is the base equation for slope formula or the slope. We will move on to word problems after this, but for now, we just want to make sure that you're able to plug in values into the slope formula and also use rise over run. If you need to look back over at this video at any time, please feel free to do so. Y'all have a great one.